sampling, or what is the population, what is sampling frame, So today I'll start with simple random sampling because they are the probability sampling techniques where every person has got, or every unit has got a equal chance of being selected, right? So simple random sampling, it is used in the quantitative social science research. And here in simple random sampling, it's, nothing is in the hands of a researcher. He just has to pick up the sample from a population and randomly, right? So why where we use this random sampling, we use random sampling at those places where we have a list of population, right? Or a list of sampling frame is there with us, right? So let's say where the population in other terms is finite, that means we have that, the information about the population. Let's say I've given the example here, survey by distributor on the customers of a Maruti car, right? If you want to, have a survey on the distributor of customers, then you may please go for the simple random sampling. But again, you have to be very much sure. Let's say you want to conduct a research on the students doing MBA from a particular university, right? From, let's say, state universities, right? So then again, number of people who are doing MBA from your state universities, you already have the list, right? So that when the list is there, when the population is small, it's finite, there you can pick up randomly, right? So here there's no set pattern in the random sample. But again, we tend to be biased, right? We as human beings, as researchers, we create biases for our own self. Let's say, suppose you want to study the purchasing pattern of the people, and purchasing pattern of the people, let's say for this you need a certain number of responses within a time frame, right? Or let's say you need to study the purchasing pattern of people during the festival season, right? So here you divide the responses uh, like into pre-lunch and post-lunch, right? uh, and what as a researcher you do, or what as a research scholar at times we do, okay fine, let's collect the responses early morning, uske baad we will give free, right? So here what is this? This is the bias which we have created as per your own convenience. You picked up the responses early morning, right? And you have completed all your data, which you were scheduled to, carry on from 9 to 10 p.m in the night. So in that case, what is this? Like, this is the bias which you have created. So in spite of this, it's a random sample, bias may creep in, right? So in this case, it would be better if you conduct a survey from 10 in the morning to 9 in the evening, so that you can have an maybe, the second half of the people, they may be important, right? They may be important part, and you are skipping just because of your own convenience. So in that case, a bias which you have created for yourself is in the case of simple random sampling. So again here, uh, estimates are easy to calculate because you have a list, right? And simple random sampling is always an equal probability selection design. But again, disadvantages: if the sampling frame is large, then this method is impracticable. Next time, the day yesterday I told you, in few research papers where we picked up the non probability sampling techniques, right? Why? Because the sample frame was not practicable, the sampling frame was not available. And again, at times minority subgroups of interest in the population may not be present. So in that case, these are the few disadvantages of simple random sampling. But here what is important is the bias needs to be avoided, because if the bias creeps into the sampling design, the randomness is lost, right? I'll give you again very simple example. The let's say you want to collect 200 responses in 10 days, right? And you being a very smart researcher, the sample you tend to complete in 4 days by taking 50 responses every day. And again, the responses maybe taken only the first half or only in the second half. They may include the bias at times, right? So here, what is how we generate the random numbers, right? Important is they can be, this bias can be reduced with the use of random number table. I'll give you an example of random number table. See your Excel sheet, right? This Excel sheet can create a random number table. This is the formula for this. Let's say you want to create, uh, let's say, is this Excel sheet visible to you all?
Yes, ma'am.
Yeah. Okay. So here in the Excel sheet only, we can uh, create a formula. Just a moment. I'll just go to the Excel sheet. Is the screen visible?
Ma'am, no, ma'am.
Just a moment. Just a moment. Just a moment. I don't know what is the technical glitch. My sheet is lost. Just give me one second. Let me open. Is the sheet visible now?
Ma'am, no, ma'am.
Okay.
Ma'am, I think you have to start presenting again.
Yes, yes. I'm presenting the entire screen again.
Yes, ma'am.
Now, is it visible? Is the sheet visible? Blank sheet?
Yes, ma'am. The blank sheet is visible, ma'am.
Yes. Now, suppose I want to generate a random number between, 1 to 300. So this is the formula, is equal to int means integer. We don't need points. 300 into random bracket plus 1. Let's say I need to create a random number between, because as list you have a list, right? You put all the numbers. I need to have a random number between, let's say 400, 1 to 400, and I press enter 18. Now what I'll do is I'll just take it to down, and 1 to 400, this will create a random numbers. See, these are the random numbers. And again, let's say you have the list with you of 450, and you can pick up 394, 291, 3144. Randomly you're picking, right? Here the computer is giving the instruction. Manually you're not doing anything, right? Again, let's say now I need a random number between 200, 1 to 200, right? So let's say if I say 200, so same here. Now you can see it's creating the numbers between 1 to 200, right? The first number starts from, okay, I started from this only. I started from this number 147. Yes, I started from this number, right? So integer is equal to integer into 200 asterisk rand brackets plus 1, right? So it is creating the random numbers, right? So these from your list you can now pick up number 147, then 42, 47, 111, 120. Again, if it is two times, then you can remove it, right? So this is how we generate the random numbers through the Excel itself. But problem with the random sampling is the biasness from the side of a researcher, bias from the side of a research scholar, where we ask them to, okay, fine, I need a 500 responses in in just 3 months. But again, sitting at the home, he just fills up the responses in just 10 days, right? Or 5 days. So that is what it is going to create. First of all, the results won't be there, and then secondly, the software will give futile results. Maybe it leads to multicollinearity where correlation is very high, and then again the biasness is there. So until and unless you are an expert in yourself, never ever play with the data. This is what I suggest to my scholars also, right? So here again, this is a random number generator, but again, problem is with randomness is you are never sure that whether this is a random number or not, right? So this was your simple random sampling. We go to now systematic sampling. Now systematic sampling is what? Systematic sampling relies on arranging the target population according to some ordering scheme. Let's say, systematic sample in very simple language. The first number is, let's say, you have a list of, let's say, 500 people, right? So first number which you pick, that is a random number, and that number could be, let's say, 4. So after 4, you can, keep on, let's say, 14, let's say 24, 34, 44, 54, 64, 74. Likewise, you can continue picking every 10th sample, or sampling with a skip of 10, right? See, let's say, but again, why it is random now? The question is, when you are, picking, why not why, where is the element of randomness? The element of randomness is here, that the first number which you pick up is a random, right? It starts with it involves a random start, in fact, right? Shall I proceed? It's clear. So yes, any questions? Yes, any questions? I think I should proceed ahead. So because here again all the elements have the same probability of selection, it is not simple random sampling, because different subsets of the same size may have selection probabilities. Because here we are, what this sentence means, that we are skipping to 10, right? And the biggest advantage of systematic random sampling is that spread is even across the population. Because in random sampling, what happened, you picked up the numbers randomly, right? Maybe, excuse me, maybe you didn't reach to the last person, right? Let's say you wanted to generate a random number from 1 to let's say 500, and you stopped at 387. What about next like 113 people? But here the advantage is even the last number has got the probability to be in the part of your sampling frame, right? So it is convenient, and an element of randomness is introduced here. So these are same things which I said. And other important is your stratified sampling. So stratified sampling is where you divide the population into distinct categories which are known as strata, right? So uh, let's say the population is very uneven, right? And it's difficult to measure that population. The sampling frame is divided into stratum, and each stratum is then sampled as an independent subpopulation. Let's say, for example, rural and urban group, right? And their attitude towards fitness study, or let's say, study on the demography in India. Now you divided the population into rural and urban group, and from there you picked up randomly, right? Even at times, when we say we are using the stratified random sampling, the question, when you in your thesis you say, okay, it is stratified random sampling, so where are the stratas? So what you can always define the stratas with the age group also, right? Let's say we divided the population into specific age groups, 80 to 30, 31 to 45, and above 45, and from there we picked up the people. So that is also stratified random sampling. So here, every unit in the stratum has the same chance of being selected. So again, adequate representation of the minority subgroups of the interns can be ensured, because in strata, in random sampling, when you pick up minority subgroups, at times they are ignored, but in stratified sampling they are being considered. So these are the stratas, right? Stratified sampling, right? Let's say there are two stratas, one with the yellow dress, another with the blue dress, and from there you pick up randomly, right? Again, this is again very simple example. If you can see, the let's say the population has got individuals with four colors, right? One, two, three, four. So you divide them into stratas as per the colors, then you pick up randomly from there. Let's say from first you picked up four, and next is the blue, again you picked up four, uh, then purple you again picked up four, and then four, 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 four is your sample, right? So this is your stratified sampling. I hope it's clear. Yes. Any questions? Yes. Any questions?
No, ma'am. Please proceed.
Yeah. Mm. Again, you need to draw a sample. Let's say, these are the four women and men, and how you need to draw this, the sample from there. This is again, they are the two stratas, right? Women and men. Let's say you are doing some survey on the university, then private and public universities, and you divide the into two stratas: public universities, private universities, or NAC accredited and non-NAC accredited universities, or NAC A plus accredited universities, and NAC B or B plus accredited universities, right? And from there you pick up the people, right? So this is again a stratified sample. But the thing is, important is, the sample has to be proportionate. You can say, see, if let's say warehouse clubs, chain stores, and small independents, this is the percentage in their population, then sample has to be like this, right? It has to be proportional sample. Disproportionate sample again will create a bias. Let's say, if warehouse you take 50% warehouse, then chain stores you take 38%, and small independents you just take 12%. It's going to create a bias, right? Then it's better, if you want to go for such type of sampling, then it's better you go for the non probability sampling techniques rather than probability sampling techniques. Then another important sampling technique is your cluster sampling, right? So now, what is cluster sampling? Cluster sampling is mostly used when there is a very big geographical spread, right? Area sampling has to be catered, right? And complete population is divided into clusters, and they make a complete survey of the cluster. Difficult for a researcher to ensure randomness in this case. For example, a country can be divided into states, then you pick up some states and use another technique to survey the individual states. States can be divided into cities, and states and cities become the clusters. Now, for example, if I'm in North India, I may pick 5 out of 9 states, and each state becomes a cluster, and the clusters among themselves are similar, but inside they may be different. Now, there is a difference between the strata. The same thing I told about strata, the same, and I'm almost, this language Same language I'm using for the clusters, but the difference I'll clear in my subsequent slide. There's a difference between the clusters and strata. Please pay attention here, right? So idea, again, at times, we go for pure clusters where in all the clusters we study, and uh, when it is not possible for us now, because nowadays, the research papers, they mostly go for either the non probability or multi stage sampling, right, which I'll explain in my further groups. Now the difference between the clusters and uh, strata is that, they may look similar, right, but groups in the cluster, they are heterogeneous. Let's go back, just a moment. Where is page up? See, this is a strata, right? Because people, there are four stratas and they are homogeneous here, right? The turquoise green color, blue color, purple color, and dark blue color, right? So this is a strata. But when we talk about the clusters, there is heterogeneity among the clusters, right? There is heterogeneity among the color clusters, because you are picking, let's say, 5 out of 9 states. So there can be variation within the clusters, right? So the difference between strata and cluster is that, uh, in stratified sampling, the strata are homogeneous, whereas in cluster sampling, they are heterogeneous. So researchers may select between the stages of separation, whether you want to go for the large clusters or small clusters, right? So again, it cuts down the cost of preparing a sampling frame, then it can reduce the travel and other administrative costs also. Difference between the strata and clusters, I have already explained, but still I would like to read it for you. The strata and clusters are both non-overlapping subsets of the population, and but they are different in various ways. Let's say all the strata are representing the sample, but only a subset of clusters are in the sample, right? So important simple difference is that with a stratified sampling, uh, the elements within the strata are homogeneous. However, with clusters, the clusters are heterogeneous. This is the one simple difference. If somebody asks what is the difference in the strata and clusters, you can simply say stratified sampling make like strata are homogeneous, and in this cluster sampling, they are heterogeneous. Important is, this is very important sampling, multi-stage sampling, because this is a very complicated sampling and which is being desired by the research journals nowadays. They are focusing on the multi-stage sampling. Ordinarily, in I would suggest, if you people are doing your research, or if you are into the mid of your research, try to, include this type of sampling if possible, with the help of your supervisors, of course, because here you try to use different combinations of techniques, right? You first of all, let's say, cluster within the cluster, or cluster combined with the stratified and convenience. Because if cluster is combined with the stratified and convenience, that means you are mixing the probability and non-probability type of sampling, right? Two levels of clusters, and mostly they are used in the combination with the convenience. I'll give you a very simple example. Just I'll see that paper I have opened. Okay. Yes. See, since being from the North India, we are doing a research with about this paddy stubble burning, right? So one of our co-authors, it is not my paper, it's his paper. So what they did, they try to follow the multi-stage sampling. Is this article visible? Data collection. Is
No,
this
ma'am.
article? It's visible? No.
Yes, ma'am.
Yes. No? Okay. I'll zoom it if possible. See now. The study aimed at identifying the impact of COVID-19 induced lockdown on various indicators of interest. Let's say, land holdings, etc. Uh, right. So what they did, we followed for sample size determining that we followed for sample size determination, and the required sample size for the study turned out to be 1051. We collected primary data from 1100 farmers for this study. So I'll show you the supplementary material also. For collecting the cross section data from the primary, a multi-stage random sampling, see, multi-stage random sampling technique was used with the district and villages as the respective stages of the sampling. Right now, what they did, at first stage, 11 district with randomly were randomly selected. सबसे पहले, this is your random sampling. Out of 22 districts in Punjab. See, here what it is showing the random sampling. Now from each selected district, 4 medium size uh, villages were selected randomly. See, what was the criteria? Criteria was population with 1000 to 2500. Right. So in many cases where the villages were small in the size, a nearby village was combined into the village cluster for the final. So here sampling. So here it is now cluster sampling also. Right. Random say we came to cluster in one district, let's say Hoshiarpur, the villages were relatively small and hence 6 villages were selected instead of 4. A complete enumeration of all the farming households were done for each selected village cluster by using at least latest voter list published in the State Electoral Commission. 25 farmers were randomly selected from each of them, making a total sample of 1100 farmers. So again, you can see how they started with the districts first of all state, then randomly picking the districts, then randomly picking the villages, and then forming the clusters, right? So this is again this your multi-stage sampling, right? So this is how the sampling is there. This is the map from, right, map of the selected districts from of the Punjab. And this is, if you want to see this is sample size is 11, number of districts is 11, then villages itne, number of small farmers, those who have less than 2 hectares, and then medium farmers, and then large farmers. So this is a combination of your random and cluster sampling which was taken. So this is how multi-stage sampling nowadays is very important, right? So again, it's again my suggestion to all of you, if you can, rather than see, depending on the sampling frame, here now we are working with the farmers, or let's say you work with the hospitals, right? So first of all, you pick up, let's say you divide the North India zone into 5 clusters, right? 5 clusters may say you pick up 3 clusters, and from those 3 clusters you pick up randomly, right? So this is again or because through conveniently and randomly you pick up the hospitals, those who are practicing the telehealth solutions, for example. And when you have picked up the hospitals, those who are using the telehealth, from there you pick up doctors who are using this telemedicine through convenience sampling. So here you are combining both. You are combining your probability and non-probability sampling. This is what is known as your multi-stage sampling. This is again, important. And multi-stage sampling is used frequently when a complete list of all population members does not exist. Important is this one, right? See. Okay, just me go to the slideshow. Now, step 1 is you define the population, is you cluster the population. I hope this slide is visible.
Yes, ma'am.
Yeah. So you are dividing the population into small clusters. Let's say here what we did. We okay. Where is that slide? So here, let's say we came out with how many clusters? 1, 2, 3, 4, 5, 6, 7. Out of those 7 clusters, we picked up 1, 2, 3, and 4 clusters, right? And in these 4 clusters, we randomly picked up the people 1, 2, 3, 4, like 1, 2, 3, 1, 2, 3, 3 people from each clusters, right? Randomly sample units within the selected clusters. It's your multi-stage sampling. I hope I'm clear. because this is very important. Yes, I hope I'm clear. Any questions? Shall I proceed? Okay. Now, factors to consider in the sample design. First of all, your objectives. What are your objectives? This is very important, right? Your objectives have, this is something which define your sample, right? Suppose, let's say your objective is to find out the relationship on two or three dependent or independent variables. So accordingly, you go for the sample design. Then accuracy. Again, accuracy is, let's say somebody is in the medical stream and he can't afford, that errors, right? He has to be 99% accurate. So in that case, degree of accuracy also defines the sample design. Because if you want to, have, let's say in our social sciences research, we generally have plus minus 5 ka error, right? So that plus minus 5 error, that again defines. But in case of medical or health sciences, we just can't afford to have that error. So as a result of which, accuracy also matters a much. We, what resources we have? Do we have, some funding? If we have funding, then we can travel all across the India or even abroad. But if we don't have funding, then we restrict ourselves to the Google forms, right? How much time we have? Like, it is a time bound research. Is the research is for, let's say, 6 months? Is it some UGC ka project which is for 1 year? Or again, it's your PhD degree which is for 3 years and extended 3 years and plus 2 years again, right? So it depends upon the time frame also. And moreover, knowledge of the target population. Suppose if I want to, survey the rural women, uh, with a medium literacy level. So then the better would be, like, suppose, and I want to know, like, their knowledge about the mobile healthcare apps or femtech apps which we call them. But again, here also I'm going to find very limited Indian women using the femtech apps, especially in the rural areas. So again, my sample would be restricted. And on the other hand, if I'm surveying the university students doing e-learning and using the online learning platforms or using gamification, so accordingly my sample will increase. And scope, what is the scope of my research? Either it is for PhD or it is for, some action research. So that these are the factors which define. And statistical analysis needs, like what type of analysis is required. If some multivariate analysis is required or univariate analysis is required, or let's say, you are doing an experimental study where only t-test is required, right? Let's say, a few days before, one of candidate from health sciences came and she wanted to do a research on infertility clinics, right? And giving the interventions of yoga and mindfulness on them, right? So in that case, they said, okay, fine, we will divide the sample into 2020 2020, and then what we will do is we'll give them, we'll have four groups. To one of the group, we'll give them yoga, then meditation, then mindfulness, and third group may yoga and meditation, yoga and mindfulness, or fourth group will be, we will not give any intervention, and then we'll see what, whether, they are able to cope up with the stress or not, right? Another research which is being done is, the research on the postpartum depression, means the depression among the women. And again, here also we are giving certain, interventions in the form of, this telehealth applications, right? So here also the sample which we have picked is very less, that is only, 100 people, 100 women. Because the women in India, they generally don't come up with their problems easily. So 100 women or 90 women, we are taking the sample and we will provide them intervention of the telehealth application, whether they are able to come up with the postpartum depression or not. So this is how, the statistical analysis what is required, right? Let's say, if you want to go for the structure equation modeling, then minimum sample size has to be, the data has to be normally distributed, and minimum sample size has to be more than 200. And again, for that covariance space structure equation modeling, that requires more than 200 data size. And if you are unable to have that size, then you go for the PLS base SEM, that is through this PLS base SEM. Uh, you don't go for the MOS that time, then time you go for PLS base SEM, right? So this is the statistical analysis which requires certain data. Now, important is how to determine the sample size, right? So, and again, yesterday also I was telling you people that, the sample has to be the representative of the entire population. Generally, the larger the sample, the better is it, right? But again, it takes more time and money. The larger sample, because the sample is larger, the data is normally distributed. The data is normally distributed, the error is less. The error is less, results are better, right? So uh, important is desired level of confidence and degree of accuracy. They are very important, right? So again, these are the methods through which we generally, how much budget we have and how much time is available. Then again, it is your decision, but I generally suggest, if it is a social science research, try to have as good as sample. Because suppose if you are doing a research on, let's say, e-learning, then the sample take more. One of my student, he did a research on e-learning. Then the sample was more than, 1029. And where we compared the academicians and students, and the academicians were 320, and the remaining were the students, right? So because let's say, suppose we are doing a research on the MBA institutions. Now in MBA institutions itself, you can see, like, the teachers are less, right? But students are more. So again, you can compare the unequal sample size also. It's not mandatory that, for comparison or for, running a model, the sample size has to be same. The sample size may be unequal, and we have the literature support for both, right? So yes, this is something which I've already discussed. This is the sample size formula, right? uh, Here what you choose is 95% confidence level. That means 95% confidence level means that you need to be 95 5. There is a, possibility of error plus minus 5%, right? And accordingly, zero point 0.5 standard deviation. Why we choose 95% confidence level here is because uh, it's okay. In our social sciences, mostly we are, we research, because the social sciences research is mostly based on the perception. It's not like, let's say, if this cohort is of 20 people who are listening to this sample size lecture, so the perception of 20 people is different, right? One person's perception is different from other. So as a result of which, the error is coming up, right? They're not thinking in the same way. If I'll say, okay, do you go for virtual try on technology while purchasing online? So what you'll say, few of you will say, okay, it's okay, it's okay, like, I'm comfortable with virtual try on technology. But at times you'll say, no, I'm not comfortable with virtual try on technology because I don't want to reveal the, my body structure or something like that, right? So that, perception varies from person to person. And margin of error is plus minus 5%. So minimum sample size is Z score. Z score is, because when we go for normal distribution, we calculate the Z score. And Z score, if 90% accuracy, it is 1.6. 95, it is 1.96. And for 99%, let's say 99% Z score, when we need 99%, when we are testing a drug, because here we cannot commit mistakes. We have to be 100%, 99% sure, fine, this drug has to be tested properly, right? So by putting the values over here, so the sample which comes out is 384 respondents. 384 respondents for social sciences research. But here again, if you put some different formula, let's say we want to have the 99% accuracy, then your formula or the number changes. Let's say you go for the census study. If you are going for the census study, अगर आप census study के लिए जा, if you're going for the census study, let's say you are conducting some research on the people who are doing, who are having cancer, or some students who are having the autism and all that. In that case, the sample size is reduced. In that case, again, you will get the limited sample size, right? um, so your accuracy, again the same thing, your accuracy also depends upon the percentage of your sample. If 99% of your sample said yes and 1% is no, the chances of error are remote, or chances of the error are less. However, if the percentages are 51% and 49%, the chances of error are higher. So again, it is easier to be sure because of the extreme answers than of the middle of the road ones, right? Because we at times we do get extreme answers. So important again here is the thumb rule for the sample size, because it's not only the formula on which we work. We work on some other. Yesterday also I was telling you how to calculate the sample size. I picked a few research papers where I told you 1:10, 1:5 ka ratio is also there, right? Let's say, so these are the latest, for research papers. Let's say here at all says the number of indicators plus the number of latent variables. Do you know what is the latent variable? I'm quoting here latent variable. Are you aware what is the latent variable? No. Okay, no issues. See, let's say latent variable is a variable uh, which has which is reflected by the indicators, right? Let's say you want to measure the service quality of a cinema hall, right? Service quality in a cinema hall. So service quality is a latent variable, because alone service quality is not sufficient. The service cinema hall may it can be measured with the help of your, let's say, um, sitting arrangement, audio, video, and PVR, any other facility, right? And so this is what is service quality is the latent variable, because here again it is being reflected by a number of indicators, right? This is one example. Another example is, very simple example. Let's say, we have our kitchen, right? So kitchen as such is nothing. Kitchen is composed of your, utensils. It is composed of your chimney. It is composed of your what we call as masalas and all that. It is also composed of your this we call the grocery items, right? So these are the indicators, and together they make word kitchen. If I'll say kitchen, so kitchen is nothing, right? So kitchen is a latent variable indicated by utensils, indicated by your masalas, fridge, chimney, etc. So this is a latent variable. In the definition of the research, latent variable is that variable which has its indicators, right? Which is indicated by um, various questionnaires, right? Or scale items, right? So previous studies also suggested that the ratio of the number of respondents to total of number of could be as low as 10 to 1. Means one scale item, 10 respondents. Let's say you have got 50 scale items in your research, and Schreiber says that for one scale item, 10 respondents. So ideally the sample size comes to be 500, or even 5:1, like, so let's say now this is the circle. This is a latent variable: perceived quality, customer expectation, customer value, overall customer satisfaction, and customer loyalty. So these are the latent variables. And what are the indicators? How many are the indicators? Like perceived quality is shown by three indicators: 3, 3, 6, 6. Perceived value has got two indicators: 6 to 8, 9, 10, 11, and 12. 12 into 10, that is 120. So the ideal sample size should be more than 120. Now minimum sample can be 120, and ideal sample, if you want to go for the normal distribution, then it should be more than 200 for testing this model through structure equation modeling, right? So this is the fifth confidence level. There is again this table. If the population size is this much and margin of error plus confidence level, this is the sample size. Otherwise, there is sample size calculator also. uh, it's available on the internet. I'll show if it is possible. Okay, sample size calculator. Sample size calculator. Is it visible?
Yes, ma'am.
Yeah. So confidence level 95%, population proportion, or if I'll say calculate, sample size is 385. Let's say I want to increase the confidence level to 99.9% in case I want to test a drug. Then calculate the sample size. 1083 is the sample size. It's very easy to calculate, no? Let's say you're doing some research where on arts or design where not much of accuracy is required. So you say calculate. So 273 is the sample size, right? So this is the sample size calculator, very easy to calculate. No? You can calculate the sample size from here also. So factors affecting sample size. First is variability of the population, like what is the population and what is the different types of what is the where is how much is your population scattered. Then confidence desired in the estimate, like how much confidence is required. Again, I'll say if 95% confidence is required or 99% or 90% confidence is desired. So accordingly, you can say degree of precision in estimating the population characteristic. I'll show what is the precision in my next slide. Yeah, this is important. Accuracy and precision. Accuracy is, in journal, accuracy we call as the degree to which an estimate based on measurements represent the true value of an attribute. Means, like, let's say you want to measure customer loyalty or let's say customer satisfaction, right? So whether the scale items which you have designed, are they measuring customer satisfaction? Aren't they measuring something else, like let's say they are not measuring something else, like easy to use or easy to understand, right? So means they are measuring what they are supposed to measure. Means the results which you are trying to get, they should be close to the truth. This is the accuracy. And precision is that, again, let's say uh, you have an instrument, right? You have an instrument, you develop an instrument, and after repeated testing it is going to give you the same results. Is If it is giving the same results, then it has got the reliability. That means it is reducing the error, it is reducing the random error. So here, accuracy is obtaining results close to truth, and precision means obtaining similar results with repeated. Suppose, let's say, you designed a scale or you designed a questionnaire for let's say you satisfaction of uh, car owners, or let's say satisfaction of e-vehicle owners, electrical vehicle owners, right? But you are using it today. Let's say after 10 years you are using the same instrument, but it is going to more or less the same results. So that means it has reduced the error, right? Again, there is non-sampling bias is present even if the sampling and analysis is done correctly. uh, that could be due to the non-sampling bias, or non-sampling error comes when you have corrected the incorrect, or you have contacted the incorrect people, right? Let's say you are doing a research on the this online shopping, and you are taking the sample of those persons who have not even purchased even once. So that is going to lead the bias, and accordingly you have either the sample the wrong people, or your measurements have skewed to one side. If we say the normal distribution, they are either left or right skewed. This is non-sampling bias. So this is the same thing which I have been telling. Once again, larger sample size increases the precision. That means it increases the reliability, but it does not guarantee the absence of bias. At times, there is non-response bias also, which arises as a result of your data collection. Non-response bias means, let's say, I told you to collect a sample of 500, right? You send your questionnaire, you visited, then made a revisits, and again 350 people were the ones who responded immediately, right? You send them once and they responded by reading. Then there were 150 people who didn't respond, but then you made repeated requests. Maybe they are your friends or so, right? They're your friends, and you just told them to, okay, please fill up the form, fill up my questionnaire, fill up my questionnaire. So what they say, they did, you find, okay, it's so lengthy questionnaire. Without reading the question, they just made the pattern 3 3 3 4 4 4 2 2 2 1 1 1, right? So in that case, the bias is there now, but there are ways to correct that bias. First of all, when this non-response bias occurs, what you do is you divide the sample into early and late respondents. Let's say 350 and 150 in this case. You calculate the mean and standard deviation of both the samples, right? And if there is a difference between them, that means bias is there. But if there is no difference between them, that means bias is not there. So quality control is more difficult the larger the sample size. So you may better, here again, bias may result in incorrect estimate also. Fine. So that is why we say the adequate sample size, as per the number of items, as per the number of estimations, or you may better off with the smaller sample size also, right? But much less bias and less precision. So I think that is all from here. Um, yes, that's all. Yes, any questions? Because I'm open for questions. Yes, any questions?
Hello, ma'am.
Yes, please be a bit louder.
Yeah, can you hear me now?